Okay, continuing with the 1.3 to 1.5 test, I am starting with number 23. We have to find all real solutions, so we don't need to worry about complex. So what I want to do is we want to get these equal to 0, so we need to subtract the 64x from both sides. That gives us x cubed minus 64x equals 0. Now we want to factor these. So I have a common x in both terms, so I'm going to factor out x. That gives me x squared minus 64 equals 0. Now that I have factors, I can set each factor equal to 0. So x is equal to 0, and also x squared minus 64 equals 0. When I add 64 to both sides, I will get x squared equals 64. When I take the square root of both sides, I'm going to get x equals positive and negative 8. So I have 0, positive 8, and negative 8. Okay? X to the fourth plus 27x. Again, we are just trying to find all real solutions, so I'm going to see that I have a common factor of x. That will give me x times x to the third. What? Okay, so x times x to the third plus 27 equals 0. And then I have factors, so I'm going to set each factor equal to 0. I get x equals 0 for one solution, and x cubed plus 27 equals 0. Subtract the 27 from both sides, you will get x cubed equals negative 27. When I take the cube root of a negative number, that's not going to make it an imaginary number. Only when I take even root values. So with the cube root of negative 27, I will get x equals negative 3. So I have my 0, and I have negative 3. For the number 25, I have a common factor of x. Then I have x to the fourth minus 5x plus 6 equals 0. I have a quadratic underneath the, or not a quad underneath, but a quadratic here in x squared minus 5x plus 6. That can actually be factored to be x minus 3 and x minus 2. And my x out in front. Now I've got all factors. I set each one equal to 0. X equals 0, x minus 3 equals 0, and x minus 2 equals 0. I get, for this x minus 3, I'm going to get x equals 3. For x minus 2, I get x equals 2. So I get 2, 3, and 0. For number 26, I need to notice that I have 4 terms here. So I'm going to draw a line straight down to split the 2 terms on the right and 2 terms on the left. I'm going to factor out a greatest common factor. The greatest common factor on the left is x squared. When I factor that out, I will be left with 2x plus 1. On the right-hand side, I have a factor of negative 9. When I factor that out, I will get left 2x and plus 1. So then I have a 2x plus 1 in common on both sides. I'm going to factor that out, so 2x plus 1. When I factor that out, what do you see left is x squared minus 9. So I have factors. I'm just solving for real solutions. I'm going to set each one equal to 0. So 2x plus 1 equals 0, and x squared minus 9 equals 0. When you subtract the 1 and divide by 2, you will get x equal negative 1/2. When you add 9 and take the square root, you're going to get positive and negative 3. So positive and negative 3 and negative 1/2. Number 27, I've got fractions and I'm trying to solve an equation. So I'm going to multiply by the common denominator of x times x minus 3. When I distribute to the first fraction, the x's will cancel. I will be left with the 10 and x minus 3. For the second term, the x minus 3 will cancel. I will be left with the x times the 12. Now for the 4, there's no denominator to cancel, so both of those are going to get multiplied by the 4. So 4x and x minus 3, and now that's equal to 0. Now I need to simplify this out. I'm going to distribute the 10. I get 10x minus 30 minus the 12x. And then I have to distribute the 4x, and I get plus 4x squared minus 12x equals 0. I'm going to put my 4x squared first because I can see that I'm going to have a quadratic. So 4x squared, let's see, 10x minus 12x is negative 2x, minus another 12x is negative 14x. So all those x terms are gone, and I'm left with minus 30. And at this point, I can do quadratic formula. So the opposite of negative 14, well, I guess I'll identify my values. A equals 4, B equals negative 14, and C equals negative 30. So x equals 14 plus or minus the square root of negative 14 squared minus 4 times negative 30 all over 2 times 4. When I simplify the radical part here, I'm going to get 14 plus or minus the square root of 676 and then over 8. The square root of 676 is 26, so I'm going to get 14 plus 26 over 8 and 14 minus 26 over 8, which will get me 40 over 8, which is 5. 14 minus 26 is negative 12. Negative 12 over 8 is negative 3/2. So those are my two answers for number 27. If I go back to make sure that both of them will work, 5 is going to be fine. Negative 3/2 is not going to cause a 0 in the denominator, so everything's good. Alright, so now I'm going to erase just to clean this up a little bit. Alright, so number 28, I have fractions. I'm going to multiply by the common denominator of 2x plus 7 and x plus 3. For the first fraction, the 2x plus 7 will cancel. I'm left with the x from the numerator and x plus 3 minus, in the second term, x plus 3 will cancel. I'm left with 2x plus 7, which will be left with the x plus 1, equals, nothing cancels out with the 1, so 2x plus 7 and x plus 3. Now I need to simplify. I'm going to distribute the x. That will give me x squared plus 3x. I need to distribute the subtraction here to get minus 2x and then minus the 7. Wait a minute. That actually has to be multiplied by this right here needs to be multiplied and FOILed. So I will distribute the x. I will get x squared plus 3x. I'm going to figure out what this product is right here, and then I will distribute the subtraction. So 2x times x is 2x squared. 2x times 1 is 2x. And then 7 times x is 7x. And then 7 times 1 is 7. So 2x plus 7x is 9x. Now I can distribute that minus. So minus the 2x squared minus the 9x and minus the 7. And that's equal to, and then I have to FOIL this side. So 2x times x is 2x squared. 2x times 3 is 6x. 7 times x, 7x. And 7 times 3 is 21. 6x plus 7x is 13x. So I get 2x squared plus 13x plus 21. Now I've got 2x squared on both sides. Oh, nope, this one's negative 2x squared. This one's positive 2x squared, so never mind. I'm going to get everything to one side, set this equal to 0. So I'm going to subtract the 2x squared. That gives me x squared minus 2x squared, which is negative 1x squared, minus another 2x squared. That would give me negative 3x squared. Okay, those are all taken care of. I have 13x. I'm going to subtract the 13x from both sides. I have 3x minus 9x, which is negative 6x, minus a 13x, which is negative 19x. Okay, those are all canceled. And now I need to subtract the 21. And negative 7 minus 21 is negative 28. So that's equal to 0. Now I'm going to do quadratic formula. So a equals negative 3, b equals negative 19, c equals negative 28. All right, I'm going to go over here. So x equals 19 plus or minus square root negative 19 parentheses squared minus 4 times negative 3 times negative 28 all over 2 times negative 3. When I simplify underneath the radical, I get 25. So x equals 19 plus or minus the square root of 25 over negative 6. Square root of 25 is 5, so 19 plus or minus 5 over negative 6. So I'm going to get 19 plus 5 over negative 6, and I'm going to get 19 minus 5 over negative 6. So that's 24 over negative 6, which is negative 4. 19 minus 5 is 14 over negative 6, and that's going to be negative 7/3. So those are my two solutions for that one. I'm going to have to give myself some room here, so I'm going to have to erase all this. So pause it if you need to write it down. All right. So let's see. Number 29. This is x to the 6th minus 2x to the 3rd minus 3. Well, it's 3 terms, but it's not a quadratic, but it is in quadratic form. So when I have a polynomial that's in quadratic form, I can use the quadratic formula and base it off of the middle term here. So instead of saying x equals, I'm going to say x to the 3rd equals. And my a value is 1, my b value is negative 2, my c value is negative 3. So I'm going to get the opposite of negative 2, which is 2, plus or minus the square root of negative 2 squared minus 4 times 1 times negative 3 all over 2 times 1. So I go through and I solve this just like I would any other quadratic formula. And underneath the radical, I'm going to get 16. So 2 plus or minus the square root of 16 over 2. So that's 2 plus or minus 4 over 2. So I get 2 plus 4. And remember, this is x cubed equals 2 plus 4 over 2, which is 6 over 2, which equals 3. And that's x cubed. So I need to take the cube root of both sides. And I do not do plus or minus because it's an odd number radical. And I get x equals the cube root of 3. And then that was 2 plus 4, so now I need to do 2 minus 4 over 2. That's negative 2 over 2, which is negative 1. So x cubed equals negative 1. When I take the cube root of negative 1, guess what? I just get negative 1. Because negative 1 times itself 3 times is still negative 1. So my two answers are x equals negative 1 and x equals the cube root of 3. Now, this last problem here, number 30, I'm going to need to get the radical by itself and then square both sides. So to get the radical by itself, I need to subtract the 2x. I get the square root of x plus 1 equals 8 minus 2x. Now I'm going to square both sides. When I square both sides, I am going to cancel out the radical on the left. That leaves me with x plus 1. And on the right, I need to write this out twice and FOIL it. So 8 minus 2x, 8 minus 2x, I'm going to get 64 minus 16x minus another 16x. And then negative 2x times negative 2x is positive 4x squared. So I get 64 minus 32x plus 4x squared. I have a quadratic. I'm going to move the x and the 1 to the right and get this set equal to 0. So subtract x, subtract 1. I get 0 equals 63 minus 33x plus 4x squared. And I'm going to use quadratic formula, where a equals 4, b equals negative 33, and c equals 63. So x equals, opposite of negative 33 is positive 33, plus or minus, square root of negative 33 squared minus 4 times 63 all over 2 times 4. When I simplify under the radical, I will get 81. So x equals 33 plus or minus the square root of 81 over 8. The square root of 81 is 9. So 33 plus or minus 9 over 8. And 33 plus 9 over 8 is going to be 42 over 8, which is 21/4. When I do 33 minus 9 over 8, that is 24 over 8, which is 3. So my two answers are 21/4 and 3. If I happen to run into a radical that isn't a perfect square, you need to simplify the radical as much as possible. Okay, that's it for this video.